It's 7:05. I guess we can start now. Hey, welcome everyone. Today we are in the second session of Big Questions. We'll be covering the topic tinkering with Arduino. So last time we had given a short introduction to Big Questions, what we are hoping to achieve here. So this is a small initiative by the SMA Tech Forum, where we are hoping to engage and engage different audiences in the tech community by giving expository talks on various subjects. We do not hope to limit ourselves to just talks. We are hoping to move on to workshops and things that would be interesting to people in the tech field. So we hope to reach a wider audience by introducing various subjects. And we also provide a platform where speakers can share their knowledge and research. So we mean to facilitate meaningful discussion through these talks and workshops. In case you're interested to speak, you can reach us through the SMA Tech Forum at malayali.org.sg. We'll also be updating all the future sessions on SMA Facebook page. So do like and follow that in case you want to receive regular updates. Before we begin, I'm Balu here. I'm a volunteer with the SMA Tech Forum. Like a few housekeeping rules, like we'll go on to the talk and Rajesh would finish his talk, and all the questions that pop up in between, you can drop into the chat. I'll be compiling the questions and asking them at the end of the session. So I'll just give a brief introduction to today's speaker. Dr. Rajesh Panicker is a senior lecturer at National University of Singapore. He has quite an experience in things related to IoT and embedded systems. So he has won the lecture, sorry, just give me a moment. Yeah, he has won the National University level, NUS University Level Teaching Excellence Award as well 3 times, which is a feat in itself. Welcome, Rajesh. I pass the stage on to you. So let me just switch the session. So hope everybody can see Rajesh's screen now.
Hello, I hope I am audible. Yeah,
yes,
okay. Yeah, good evening, everyone. And thanks, Balu, for the introduction. And thanks, SMA, for inviting me to talk to you about this hardware platform called Arduino and what you can do with it. Okay, so hope you can see my screen. I'm not using PowerPoint. Instead, I'll be using a wiki. This wiki is publicly available, so you can see the URL here. Just make sure that you have HTTPS and not HTTP in front. Okay, so if you just type it down without HTTPS, it wouldn't work. Okay, the reason why I am using wiki is so that I can give appropriate links at appropriate places to external resources, and it's very easy to navigate back and forth between topics, which isn't very possible with, for example, a set of slides. Okay, so hope that's okay with you. And if you want to follow what I'm showing, you can go to this URL. I hope one of the organizers can put in this URL in the chat window so that you guys can go into the link. Okay, so let's get started. Well, what is Arduino? And before I talk about what is Arduino, let's talk about what is a computer. What exactly is a computer? Well, if you ask 10 different people, you will probably get 10 different answers, right? Because a computer means different things to different people. Okay, but at the most fundamental level, you can think of it as a digital data processing machine. And what is digital data? Data that can be represented entirely using a bunch of ones and zeros. Okay, so any machine which can process this digital data can be called a computer. Yeah, and where do you find a computer? Well, you have it all around you. And the estimate is that in a developed country, the number of computers per person is above 50. We just don't see it, but it's all around us. For example, your TV has a computer inside it. It's not just something which shows a picture. Unless your TV is from like 1990s, it has a fairly good computer inside it. So does your washing machine. So does your wireless router. so does your Google Home, okay, Google, do this, do that kind of stuff, right? So it's all enabled by a computer. A projector that you might use in a lecture theater that has a computer inside it. So computers are all around us. Okay, so don't think of computer as the PC or the desktop or laptop that you have right in front of you. Even your mobile phone, it's much more of a computer than a phone, right? Calling it a phone is no longer a correct terminology. It's a bit of an anachronism, because calling is a very secondary or tertiary function of the so-called phone, right? Now, what exactly is Arduino? Arduino is just a small computer. Okay, nowhere close to as powerful as the computers that you might have in front of you. The computer that you have in front of you can process several tens of billions of so-called instructions or a simple arithmetic operations per second, several tens of billions of them. Whereas Arduino is something which is much less powerful. It can deal with only a few million per second. And even the size of data that Arduino can deal with at a time is much smaller as compared to your modern computer. Okay, 8-bit versus 64-bit. 64-bit can represent probably much bigger than the biggest number you can imagine. Whereas 8-bit is enough only for representing between 0 and 255. So you see, Arduino is a much less powerful computer, but well, it's good enough for a lot of interesting applications. Okay, I'll show you some of the typical applications or sample applications later. But Arduino is essentially an open source electronics platform based on easy to use hardware and software. Now, this easy to use part is particularly important, because if you have done your undergraduate degree in electronics or something, in early 2000s or 90s, you would know that programming a small computer like Arduino wasn't an easy thing at all. You needed a dedicated programmer, a fairly complicated piece of software, and this programmer was typically available only in engineering college labs. So it's not something an average person can on the street could have used. Okay, the barrier to entry was very, very high. Then somewhere in early 2000s, a bunch of people who used to gather in a certain bar in Italy, and the name of the bar is Arduino, by the way. So they got this idea that things should be much easier for average people to use. You shouldn't require a degree in electronics or computer engineering to do cool stuff. And they decided to name the platform after the bar in which they used to meet. Okay, and well, people when they are drunk get all sort of brilliant ideas, right? So this was one brilliant idea which really changed the world. Okay, now even secondary school students can very comfortably do really cool stuff. Okay, which was unimaginable 15, 20 years ago. So what can Arduino do? It can read inputs from so-called sensors, like for example, light on a light sensor or the finger on a button, or even a Twitter message, and turn it into an output. For example, activating a motor or turning on an LED or turning on a bulb or light or publishing something online. All these things can be done quite easily. Now, getting an Arduino board is kind of like getting a helper. Well, it helps, but it doesn't solve all your problems unless you tell the helper what exactly is supposed to be done. So for example, if you are somebody who can't do without a coffee at 8 a.m. in the morning, you have to tell the helper, okay, one of the tasks you should do is to prepare a coffee for me. Okay, but a computer is not as smart as a helper. You have to be a bit more, not a bit more, a lot more precise. You have to tell the helper, okay, here is where you can find the coffee powder. Here is where you can find the pan, heat up the water. When the water temperature reaches so and so, put the coffee powder, add sugar, so on and so forth. So you have to give a detailed list of instructions. Okay, and the helper will just follow the list of instructions and you get your job done. So very similar when it comes to computer hardware. Okay, computer hardware is something which requires a list of instructions so that it can do the job for you. And that list of instructions is essentially your software or program. Now, Arduino is not just hardware. It's not just the software that is required to program it. Now, to create this list of instructions, you require another software. Okay, I'll show that part later. Now, it's not just the hardware, it's not just the software. It's a complete ecosystem where you have your students, hobbies, artists, programmers, professionals, a lot of different people from a lot of different backgrounds who have used this platform and who have made contributions to the platform. And that has added up to an incredible amount of knowledge that is, for the most part, freely available and easily accessible, and you don't have to pay anyone to use it. So that is where this open source part comes in. That is, you can get the software, you can get the hardware design, you can modify it the way you like it without asking anyone for permission, without really paying any royalty to anyone. So that's the beauty of open source. Of course, the hardware itself is not free. Of course, no one is going to make it for you for free. So the appropriate electronic components in the hardware, like the chips, etc., will have to be purchased. Okay, or you can purchase the ready-made board itself. Okay, but the point is that you can modify it the way you like without asking anyone for permission and without paying any royalty. Now, over the years, Arduino has been the brain of thousands of projects, from everyday objects to very complex scientific instruments, etc., etc. And it's very inexpensive, depending on the specific board. In fact, Arduino is not just one platform or one board or one hardware. There are a number of different boards under the banner or under the umbrella of Arduino. Okay, it's all very inexpensive. You are looking at a few dollars to few tens of dollars for the basic hardware itself. And it's cross-platform. The program which is used to create the program, which is what we call the integrated development environment, which I'll show you later or very soon. So that works on pretty much all platforms like Windows, Mac OS, Linux, even Android, and there is even an online version. And it's simple, clear programming environment. So a lot of difficulties associated with programming, which can be intimidating for a beginner, is sort of hidden, is sort of done behind the screens for you. So you don't have to write a lot of code. You don't have to write complicated programs to get things to work, to do interesting stuff. That's the idea. And it being open source allows you to modify it the way you like. Like, for example, if your application requires that the whole thing is of very small form factor, that is miniature in size, well, take the hardware and miniaturize it yourself. No one is stopping you. So it can be adapted to meet the specific needs of your application quite easily. And the software keeps growing through the contributions of the users worldwide. For example, you want to attach another hardware component to the Arduino and read some data from it. Okay, whatever that hardware is. Chances are that someone has already done that before you. Okay, so you don't have to really reinvent the wheel. You don't have to really start over from scratch. Use what is already available, tweak it a bit here and there to meet the requirements of your specific application, and you're good to go. And that is the beauty of Arduino, and that's the beauty of it being open source. Okay, now I'll show you some sample applications. In fact, if you go to this link, you can see a number of interesting projects. These are specifically IoT related projects, Internet of Things, which are essentially Arduino projects with internet connectivity. But if you just Google for Arduino projects, you will get thousands, or you will see thousands and thousands of pages, tutorials, websites, which talk about all these. Okay, so let me just show you a couple of sample applications. So let me just start off with something which secondary school students have done a few months ago when I conducted a workshop for them. So you can see this is what we call an M board, which is nothing but a robotic platform which is based on Arduino. So Arduino is is the brain of this platform, but it has other stuff like you have some motors, you have wheels, etc., and you essentially have a complete car. And by programming it, you can make it to behave the way you want it to. So here you have a project, or the secondary school students did a project where it has to solve a maze, and at some appropriate points, it has to do certain appropriate actions. And the actions that they are supposed to do depends on the color detected. So they use some kind of a color sensor to detect the color and do certain actions based on that after stopping. So you see there, there is a black line. So they are supposed to detect the black line, stop, and then detect what is a color above it, and then do some actions based on that. So you can see, it's stopping. So yeah, so that's just a very simple application. This is something which these students do manage to do in a matter of a few hours. This is another subject I teach, where it's a first year subject. So students build a miniature satellite based on Arduino. And since we can't really, launch a real satellite in a cost-effective manner, we just launch it on a drone. So they launch it to a few tens of meters above the ground level, and you can see that they are receiving data from the satellite using a ground station, which itself is made using Arduino, which in turn is connected to a computer which logs all the data. So this is a first year subject on exploratory satellite design for those who are interested in building satellites. And eventually some of these students have went on to build actual satellites, which have been or has been launched to the space. Okay, I don't know whether it still works, but it used to be working until a few months ago. And this is another first year subject which I was involved in, where they are supposed to create a small, disaster management robot, where they were supposed to complete a certain course where there were obstacles and they had to follow certain time limitations. Like at certain points, they had to reach at certain fixed times, because in disaster management, timeliness is important, right? If you go too early or too late, it might not be good. So they had to follow certain timeliness and, well, complete a certain mission. So I won't go through the complete video. The playlist is provided in the wiki itself, so you can go through it. And this was their eventual product. So you can see it can go through some fairly rough terrain quite easily. It can detect obstacles, etc., etc. So you see, all these stuff are, I would say, fairly easy to do. None of that requires several days or years of effort. It's usually a few hours of effort. And this was another project done by my third year students, a smart parking system. It exists, right? So they just did a miniature version of it using, this was not using Arduino, but something very similar to Arduino. It's a microcontroller or a small computer, very similar to Arduino. So it's a vertical parking system. And this was also done by my third year students in computer engineering. It's a blind navigation system. So the Arduino platform is connected to a bunch of sensors, like obstacle detection using ultrasound, kind of similar to how animals like bats, dolphins, etc. detect obstacles. And it had a bunch of other sensors like acceleration sensors, rotation sensors, etc. And eventually all this data was fed to another small computer called Raspberry Pi, which we won't be covering today, but something which is a bit more powerful than, not a bit more, fairly more powerful than Arduino. So it was done using, this data from Arduino was sent to the other computer, which gave audio guidance or sound-based guidance. So it will tell the person, go left, go right, etc., based on the starting point and the end point that you have entered. Kind of very similar to how Google Maps, once you give the starting point or your current location and the end point, allows you to navigate, right? But here it's for a blind person and it's indoors. And the challenge here is that, your GPS wouldn't work indoors. So figuring out where exactly you are indoors is very challenging. And that is done using a bunch of or a combination of sensors. And all these sensors or most of these sensors were read or interfaced using Arduino. This is another project that was done by some third-year students in electrical engineering. This was again for an assistance system for the blind, but it was not a navigation system. It's a blind typewriting system. So if you don't have a keyboard, you can still type, and based on your finger movements alone, the system is able to figure out what you're typing. So you don't really need a physical keyboard. Just need to have these sensors mounted on your fingers, connected to a microcontroller. By the way, this was also not done using Arduino, but something very similar. Okay, another small computer similar to Arduino. So you can see without a keyboard, they are able to enter various characters. Of course, it's a bit slower than the correct keyboard. I mean, sorry, the real keyboard, but it's still possible. And you don't have to really type. So there is the possibility of mistyping, that is pressing a wrong character, is sort of minimized. A wrong key is minimized. Okay, now these are some of the projects that some of my students did in NUS at various levels. Now this was a small project that I did for my wife. So for our anniversary, we thought I thought, okay, giving flowers is so mainstream, so old-fashioned, right? You just need to go to the shop and get it, and the flowers wither away in a matter of a few hours or few days. So I thought it's a better idea to give something a bit more meaningful and something which lasts. And I gave it to her about 5 years ago, and she is still having it, and she still turns it on. So you see, this was also done using Arduino. Just a bunch of light emitting diodes connected to an Arduino, which displays a message. Okay, so it's a good way to impress your boyfriends or girlfriends or husbands or wives. Okay, probably a lot more meaningful than buying something directly from a shop, right? Now there are a number of other projects that I have linked here. Like for example, here a nice LED cube system where you have LEDs lighting up in a certain manner. The whole construction information is given in the video, or guidance is given in the video. So you can see it's a bunch of LEDs which are controlled using Arduino Uno, or one of those Arduino platforms. And then, you have robotic stuff, a mini 3D printer. So this is a 3D printer which is made using or controlled using Arduino. '3D printing fundamentally involves moving a certain head to the appropriate position and extruding a molten material, like for example plastic, right? So that control is done using Arduino. And then there is this persistence of vision globe, where it's essentially a metallic arc with LEDs mounted, which is rotated fast enough that it gives you the illusion that it's a circular or spherical display. That is a display with LEDs all around, when in fact the LEDs are only mounted on an arc or a circle, not as a complete sphere. And then there are a lot of other examples as well, like for example home automation, like using an app to turn on and turn off stuff. So you see, using an application to turn LEDs on and off. And LED metrics. This again is a very popular application. It's actually very, very, very easy to do. You just need to buy that LED matrix, connect it to an Arduino, and then write your program. And here again, like I mentioned before, you don't have to really start from scratch. There are a lot of example programs available on the internet. So just download it and tweak it a bit here and there to suit your requirements, and you're good to go. So you see, there are a lot of things that you can do with Arduino. Now, there are a lot of different boards which are under the banner of Arduino, each of them which has its own limitations and its own capabilities, and difference in, I mean, they come in different size, shapes, etc., etc. Like for example, for miniature applications, you would want to use an Arduino Nano, whereas if size is not a concern, whereas if you want to connect to a number of different devices, you might want to go for something bigger like Arduino Mega, so on and so forth. So one of the most popular Arduinos, so what people think 90% of the time when you mention the word Arduino is this board called Arduino Uno, which is by far the most popular board, which had been around for quite some time, and which is very widely used and very cheap. So you see, the board looks like this. This is based on a small computer plus a bunch of stuff around it. Like for example, you have all these pins which allow you to easily connect this particular board to other devices, other external devices. Okay, like for example, sensors, actuators, etc., etc. I'll talk about sensors, etc. very soon. Now, this essentially is the brain of your system, whatever system you are building. Okay, so this is a chip, which is a mini computer which does all the processing. But a brain without a body isn't particularly interesting, right? So you need a bunch of body parts. And those body parts are essentially separate hardware that you connect to Arduino. And the connection can be done using wires, but there are also those boards which are made in such a way that you can just plug it onto the Arduino board. So you don't have to make any hardware connection at all. Just plug it in and the required functionality is available for you. Okay. Now these boards contain sensors or actuators or input devices or output devices. So any device which gives information to the computer, and here the computer we are talking about is the Arduino board, is an input device. For a standard computer, the input devices are like webcams, a keyboard, mouse, etc., etc., microphone, and output devices are your displays, your speakers, etc., etc. And for your phone, there are additional inputs and outputs like touch screen, your notification LED. Touch screen is an input, notification LED is an output. Your vibration vibration output, vibration is an output. Like for example, the one which allows you to figure out whether you have incoming calls without keeping your phone on loud mode. So all those are outputs. And there is another interesting sensor that is there in your phone. Like you have this feature called auto rotate. So when you hold the phone in portrait mode, it's in portrait. And when you rotate your phone, then, well, the content also rotates, right? How does that happen? Because there is a sensor inside the phone which allows you to detect the direction of acceleration due to gravity. Earth is pulling us down all the time, right? And that acceleration is your acceleration due to gravity, G. So there is an accelerometer sensor or accelerometer, which is a sensor inside your phone, which keeps reading the acceleration. And once it detects that, okay, the direction of acceleration has changed, it will cause the display to be rotated appropriately. So the processor or the computer inside your phone keeps reading these sensors. And once it detects that there is a scenario which requires some response, some change, it will make the appropriate change. And then that appropriate change will be reflected in your output. Like for example, in the case of a display, it will cause a rotation of the display, right? So So these sensors, actuators, and Arduino together, form a complete system. And that's how you build interesting stuff. Now, how do you write your program? What I just talked about is a hardware part, like, connecting the various hardware devices or boards together. But that is not the complete story. The story will be complete only if you give a list of instructions to the computer on what exactly is supposed to be done. And that list of instructions is what you call your program. And your program is typically written in an English-like language. And in case of Arduino, it's written in a language called C++, or a simplified version of C++. C++ is a fairly complicated programming language, but the good news is that you don't have to be anywhere close to being an expert in C++ to do interesting stuff in Arduino. You can get started in a matter of a few hours, really. And you don't even need to know C++. There are some tools which are available online as well as installable ones, which allow you to do all this stuff graphically. Like drag and drop the various building blocks together, connect them, and that becomes your program. So here is where you have instructions on how to download and install the so-called integrated development environment. I'm not going to go through all the steps, but the good news is that it's all very simple. So your Arduino Ide, once it is installed, looks kind of like this. So the first thing that you would note is that it's very, very simple, you see. It has a very limited number of menu items and buttons, etc. Okay, much less than almost any typical software that you would come across, because Arduino designers follow the KISS philosophy. You know what is KISS? Keep it simple, stupid. Okay, so have only those barely required functionality so that it wouldn't be overwhelming for beginners. Okay, so Arduino doesn't really intend to be everything for everyone. Of course, if you want to be a power user, there are sufficient functionality, or there is sufficient functionality available for you to do that. But a beginner wouldn't need all of those. So you see, there are very limited number of buttons. So the first one, this one is essentially to create a new file, open, save, then check whether your program is grammatically correct, syntactically correct, and then to program your board with the required program. So the basic structure of your program looks kind of like this. I'll talk a bit more about it later. You don't have to really understand too much, but I'll give a brief overview later. But the point is that this is a place where you write your program, and this is to check whether your program is okay. So you see, done compiling means your program is okay. Now, what exactly do you do by programming? You give a list of instructions in an English-like language, but this language is not something the computer understands natively. So this program has to be converted into a bunch of ones and zeros, which the computer or the Arduino can natively understand. And once it can understand, it can execute it, or it can deal with it, and you will get your job done. So that process is called compilation. So you write your program, compile it, and upload it to your Arduino, and you're good to go. Before that, there are a couple of steps, like you have to select which board you are using. And here I am using what we call Arduino Uno. And then you have to select the appropriate USB port or COM port that you have connected the Arduino to. Okay, and the instructions regarding how to find out which port it is given here, and it is simple enough. Okay, so you just go to port here, and you can see possibly more than one port, especially if you have other Bluetooth devices, etc., of which you have to figure out which is the port, or which is the connector to which the Arduino is connected to. And one simple way to figure that out is just pull it out and see which one disappears. Okay, and that will allow you to figure out which port it is. And once you do those two settings, you are more or less good to go, and you write your program and program it, and you are done. Now, how exactly do you write your program, or what exactly is a program? I have given some basics of programming here, but this is just a short introductory session, so I won't really go through all the details of how to write a program. But there are two ways in which you can write your program. One is using text, which allows you a lot of flexibility, but which can be a bit intimidating for the beginner. Another easier possibility is using blocks. Unfortunately, the Arduino software itself does not support blocks, but the good news is that there is an online version of it which supports the blocks. And that website is Tinkercad. Okay, it's an amazing website from this company Autodesk. The same company which makes AutoCAD software, which is very popular, right, among designers. So you can just create a free account. It's free for all. Just create an account, or you can log in using your Google ID and go to this tab, circuits. You can create a new circuit. And you will get a canvas, and you will get a sort of a shopping cart on the right side. And you can just type the name of the stuff that you want to get. If you want to get an Arduino board, Arduino Uno, you get it like this. And if you're not happy with this landscape orientation, you can make it portrait by clicking this button. So it's a bit laggy because Zoom is a bit processor intensive. Yeah. So you see, this is the Arduino board, and this is very, very similar. Looks more or less exactly the same as how a physical board looks like. Actually, I can show you a physical board here. Or maybe I'll show the physical parts later. For now, I'll just go ahead with the virtual looks, or the virtual board. The real board looks almost identical. Now you see here, this is your Arduino board, the same as the board that I had mentioned earlier, which is the most popular one, Arduino Uno board. You can see there are a bunch of digital inputs and a bunch of digital outputs. I'll talk about those later, but to write your code, you can just select the option from here, like you have blocks plus text, or text. So using blocks, you can just drag and drop the required block from the left-hand side, depending on the functionality that you want. And then you can just click Start Simulation, and we are good to go. Okay, so the first program that I am going to do is essentially to blink a light emitting diode. LED, you might know, right? Light emitting diode. So there is a small LED which is labeled L here, which is connected to this particular pin called pin 13. So all these pins 0 to 13 are digital input output pins. So all these pins can take in a digital input, a 1 or 0, and it can also give out an output which is also 1 or 0. And here pin number 13 has a built-in light emitting diode connected to it, so that you don't even have to connect an external light emitting diode to see it lighting up or see it blinking. So what I'm going to do here is I'm going to use the set built-in LED. So that's a block that I can drag from here. And this is a default bunch of blocks that will be there when you start a new project. Set the built-in LED to high. So that will cause it to turn on. And then I will turn it off. But there is something in between. Why should I have something in between? What am I trying to do? The first program that I'm trying to do is to blink an LED, to turn it on, turn it off, right? Like for example, if you had a switch that is controlling a light, how do you blink your light? Turn it on, turn it off, turn it on, turn it off. And you can do it manually, but you would do that only if you have nothing better to do, right? So that's why you have the simpler computers to make your life easier. But there's a small problem when you use a computer or some kind of an automation to turn it on and off. Even though this Arduino is very slow, compared to other computers, it's still very fast. It can turn an light emitting diode or a bulb on and off a few million times a second, a few million times a second. And if it is done that fast, will you be able to see it blinking? Not really, right? So you need to turn it on, wait for some time, turn it off, wait for some time. And that waiting period has to be of the order of 1 second so that you can see it blinking very clearly. And then you start your simulation, and it simulates the actual scenario where an LED blinks. So you see, this is exactly how it is done in real life too. Now I will show it using a real system. I guess I will have to stop sharing. Give me a sec. Okay, otherwise I'll just use my webcam. I was hoping to switch to my other webcam to show it to you, but I'll leave that. So I will use the program instead, because the Arduino Ide does not allow you to use these blocks. So let's look at the equivalent program. You can actually see the equivalent program if you change the option to blocks plus text. Okay, so the moment you change anything here, you can see the corresponding program getting changed here. So here you see the corresponding program looks kind of like this. So the pin mode is essentially to set the pin number 13 to an output, because each pin can be an input or output. So you need to do something to make a particular pin, in our case, pin number 13, which is having the LED connected to it, an output. So pin number 13 is configured to be an output, and that is some kind of a setup, some kind of a setting that you have to do before you can do anything meaningful. And all those settings, those one-time thing that you do is put under this banner. We call it a function called setup. Okay, so everything that is supposed to be done once. Okay, now everything that is supposed to be done repeatedly is put under this thing called loop. Okay, I'm not going to go through it in much detail. There are a lot more details available on the wiki. So if you just go through it, you'll already get a fairly good idea. So how do I turn it on? So digital write is to write a digital value to a pin. And here the pin we are using is 13. And we are writing a high to it to turn it on. And then we wait for some time. And that wait is introduced by something called a delay. And I give 1,000 here, which will correspond to 1 second. So you give the value or the amount of time we need to delay in milliseconds. And then you turn it off by calling this so-called function or command digital write again. But this time you call it with low. Okay, so this is kind of an input to this command, and we are commanding the Arduino to turn it off, to turn pin 13 off. And then you wait for some time. And whatever you write inside this loop part gets repeated. That is, it gets executed over and over and over. So it will turn on, wait for some time, turn off, wait for some time, and the whole thing gets repeated over and over. Now, I can just copy paste this code into this so-called IDE. And then I just need to connect an Arduino. I just connected the Arduino board here. So if you look at my webcam, you can see the Arduino board here. And now I have to ensure that the correct board is selected, the correct USB port is selected, or the COM port is selected, and I can just click upload. Okay, I just need to save it somewhere. I'm just saving it at some random place for now. And you can see, you might be able to see in my webcam that there is an LED blinking. Yeah. And now how do I change the speed of the LED? If I want to make it to blink much faster, just change this 1000 to something else. Like for example, if I change it to 200, then it will remain on for 200 millisecond, that is 0.2 second. Then it will remain off for 200 millisecond. So you can see it will blink much faster than before, 5 times faster. So you see, you might be able to see it blinking much faster, right? Yeah, so it's about as simple as this. Now, you might say LED is a fairly simple device, right? How about something more complicated? So one example for a more complicated device is, for example, an LED or LCD screen, a 2-line LCD screen like the one you will see in on vending machines, right? For example, it will look kind of like this. So you need to make the appropriate connections, and you don't have to really memorize any of these connections. Even I myself don't really remember every single connection. The good news is that you just Google for it and you will see all these connections. Just make sure that you make the connections correctly for each device. Okay, and then you need to write your program. So here are the connections. So you have an Arduino here, an LCD here. In fact, you can see that LCD module here. If you want to add one more LCD for whatever reason, just drag it onto this canvas and you can just make the connections like this. For example, if I want to connect it to this thing called GND, GND is ground, like negative, I can do like this. And then if you want to use a different color, and it's a good idea to use different colors, because if you use the same color, your circuit will look very cluttered, and it will be hard for you to figure out what connections have been made, what are left to be done, whether any connection is wrong, etc., etc. And that process is what we call debugging. Okay, so use different colors so that just by looking at the color, you will have some idea of what connections are being made. Okay, here I'm not going to use all those. I just go with the actual connect or pre-built connections, and then I will have to write my code. And here the code is already written, and you can see that there is some code which is in brown color. So this code is what we call a comment. It is not something which is executed or which is done by your Arduino. These are just for users to read. So you see something which is enclosed between these two so-called symbols or combination of symbols is just for humans to read. So this is so that if you give your code to someone else, that someone else will be able to get a fair amount of information from your code. The actual code that gets executed is only those parts which are in black color. And you can see there are only like 1, 2, 3, 4, 5, 6, some 6, 7 or 8 lines of code to show something on the LCD. And even this code is something you don't have to write from scratch. These kind of codes are readily available on internet. Just Google for it, download it, and use it, right? And if you want the message to be different, just change the message here. So here, lcd.print means print on the LCD hello world. Okay, and then it will also print the seconds which are progressing one by one. And then just start your simulation, and you can see the seconds incrementing. But here the seconds won't increment every second because it's a simulation which is a bit slower than the real scenario. Okay, but you see it quite easily. Now, if you don't want to make all this wiring yourself, you have an easier option. That is, I had talked about those ready-made so-called shields that you can buy from the market. So this is a shield. You can see in my webcam, this is a shield which has the LCD connected, and all the connections here are in such a way that all I need to do is to plug it in. And it's always a good idea to unplug from your computer before you plug in or make any connections. So here I am just making this connection like this, press it in, and my connection is made. And this is readily available in the market. You can buy this LCD screen with the appropriate connectors for $5. Okay, and then just make the connection. Yeah. And now you don't see anything because the program was here, whereas I need to do the programming on my computer and download it to this particular Arduino board to get started. And you can see there are some examples which cover a lot of different sensors and a lot of typical applications. So here you can see there is a liquid crystal example, and there are a bunch of examples, like for example, if I want to do the hello world, the exact same example that we saw in simulation, you have it here, but there's a slight change that you need to make, because the pins which are connected to this board are a bit different from the example, and you can find that by Googling. So you need to make a minor adjustment, and these adjustments are already available on the internet. So again, you don't have to start from scratch. Just Google for the specific board or specific hardware that you are using, and you will already see tutorials on what to change. So I made a minor change here, just one line change, and I'm just uploading it. And you can see the hello world and the 1000 millisecond, that is the numbers incrementing once every second. And you see this program is exactly the same as the program that I had in simulation here. So you see, it takes literally only a few seconds for you to get started with such cool stuff. Now I'll show you a few more examples before I stop here. A lot of other technicalities and technical details are given in the wiki. So you can go through it step by step, try out things, and in a few hours, you'll be good to go. Okay, and no real programming experience, prior programming experience is required to create simple to moderate applications. Of course, doing things which are very complicated, very optimized, etc., will of course require more advanced knowledge. But doing fairly, intermediate level complexity stuff, doesn't require that much of an effort, that much of knowledge. And if you use this Tinkercad software, you can try out everything, including hardware connections, including your programming for the most part in simulation before you actually try out on the real board. So you don't have to worry about possibly making a wrong wiring, wrong connection, and ending up spoiling the hardware. A wrong connection can spoil the hardware, even though Arduino hardware is fairly robust. It's not so easy to spoil. Okay, but still, if you are not careful enough, nobody can help you. Okay, so make sure that you look at the connections once again with your reference connections to make sure that your connections are correct before you turn it on. And never change any connection while the power is on. That's the idea. Okay, that will keep you safe. Now I'll show you a few more examples. Like here, there is a remote control. A remote control to turn LEDs on and off. And here it is LEDs, but with some minor adjustments, it could be real lights, at your home. And it's much simpler than you might think it is. You see, the amount of hardware connections is quite minimal. And to change the LED to a light, all you need is a component called a relay. I'll show you an example with a relay next. And you just use that relay and you will be able to control a real light or pretty much any appliance. Like for example, it could be a fan, it could be a TV, it could be any device. And this remote is a very widely available remote. You can buy it for a few dollars on those websites where they sell all this stuff. And you don't even need to find this or buy this remote. You can take any remote, pretty much any remote that is available. Like for example, you might have remotes of equipment which has already died, right? Which you are no longer using. You can take that remote, But if you're taking a random remote, it will take a bit of an effort to figure out the codes corresponding to each button press. So when you press a button, it emits a certain infrared code that is received by a certain receiver. And here the receiver is this. But for an actual device like TV, this kind of a device is built into the front part of your TV, front panel of your TV. So that receives that code and takes the appropriate action. And here the program is written in such a way that if the code corresponding to 1 is pressed, 1 LED will light up, 2 will light up a second LED, and so on. And let's start the simulation. And you can see when I press the button 1, an infrared is emitted, which is sensed by this infrared sensor, which is again a very simple device which costs only a few cents. And that is connected to this pin number 11. So this pin number 11 receives that information, and you have a software. You write your code here, and that software reads from pin number 11, figures out what is a code that is sent by the remote control, and takes an appropriate course of action. And this again is a sample code that is available on the internet. And if you want to have more devices connected, it's just a matter of, mostly copy paste and changing a bit here and there. And here you see these are the so-called codes, corresponding to each button press. And if you don't know the codes, there are sample programs available on the internet which allow you to figure out what is a code that you will see when each button is pressed. And you just note down the code and then change your program, the program which is supposed to control all these appropriately, so that when a particular code is received, you will turn on a particular device or turn off a particular device. Okay, so quite simple. Now, another example for an home automation. And these are the kind of devices that you will find in some of those HDB blocks, to turn on a certain light for a certain amount of or period of time when motion is detected. So here I have a light bulb, and here I am powering it from 9 volt, but in reality, you would be connecting it to your mains, that is 220, 240 volts mains. And your Arduino is used to control something called a relay. A relay is essentially a switch where instead of manually turning it on and off, the on-off command is sent from your Arduino board. Okay, so this Arduino board gives only a 5 volt command, and that will cause the relay to be activated, which will make or break a connection between these two. So when the Arduino says, okay, turn it on, so when it gives a 5 volt here, a connection is actually made between these two. And this relay is made of a very simple electromagnet. You yourself can make a relay on your own if you have the sufficient resources in a matter of a few minutes or hours. Okay, but relays, when it deals with high voltage, is something you have to be extremely careful about. So, I don't really recommend dealing with any voltage more than like 15 volts without proper supervision of somebody who knows what's going on. Okay. Anything up to 15 volts is very, very safe. It wouldn't hurt you at all. Okay. The worst thing that you can do is to damage the components or hardware. Okay. One exception is lithium-ion batteries. So if you are playing with stuff, don't use lithium-ion batteries. If you're not convinced, just go to YouTube and search for lithium-ion batteries exploding. And all you need to do is to see one video, and you'll be very careful. You probably won't dare to do that. Okay, so other than lithium-ion batteries, any voltage below 15 volts is absolutely safe. Now, here I have something called a motion sensor. A motion sensor essentially creates some kind of an infrared map of the surrounding. And when that signature or that map changes, and that happens when a person moves around, because we all emit infrared radiation, right? Any hot object emits infrared. So when it sees that there is a change in the infrared signature, it will activate, or it will give a certain command or certain input, which is read by your Arduino, and the Arduino will cause the relay to be activated so that the light will be turned on. So here I have written the code in such a way that it will remain activated for 5 seconds, if I recall correctly. So you see, here you can simulate that movement by moving something here. So if you click this and if you make a movement, this is like how a person or a live object moves. So you see the light remains on for 5 seconds and then it will turn off. And then you move it again, it remains on for like 5 seconds. So you see the number of connections that you need to make, etc., are quite minimal. And these are all components which you can buy quite easily and for fairly cheap. So you see, you can do all this interesting stuff. Now I'll show you another couple of examples before I end the session. Oh, by the way, maybe I should go forward and I'll show you the code corresponding to it. It's very simple, so I thought it's a good idea to show it to you. So this is using blocks. The corresponding text is here. So if you're using Arduino Ide, you have to just copy over this text onto the Arduino Ide here and then program it and you're good to go. Now, if you're the blocks picture is just this. So you see here, if I am reading it from pin number 2, so because the sensor input is connected to pin number 2. If pin number 2 is equal to high, then pin number 3 is set to high. Pin number 3 is my output, which is connected to the relay. And then you wait for 5 seconds. This is to ensure that your light bulb remains on for 5 seconds. Okay, otherwise you turn it off. So 5 seconds later, if motion is no longer there, then you turn it off. That's the idea. So you see, it's very simple to drag all these blocks together and connect them together to express what you want to do. Now, if anyone is interested, I can share all these with you. Oops. But it's not a bad idea at all to just try out all this stuff yourself. Okay, so another one is an LED strip. And I have programmed in such a way that it will first go clockwise and the inner one will go anti-clockwise. And once it is done, it will wait for a while, a short while, and then it will change the color. And the colors are set to be randomly generated. Okay, so I can't predict what will be the color generated. It's just using a random color. And here the program is like this. Again, it has a few lines of code, but I didn't write most of this stuff myself. I just took a code from the internet and changed maybe 2 or 3 lines here and there, to account for, the change in shape, the number of LEDs, and the pattern in which I had to turn it on or off, etc. And that's about it. Some 4 or 5 lines of code changed here and there, and we have the required pattern. And another one is one of the exercises that I have mentioned in the wiki, where I have an ultrasound sensor. And depending on the distance of an object from ultrasound sensor, this ultrasound sensor works based on the same principle that bats and dolphins use. You send an ultrasonic pulse and look at the time required for you to get an echo. And that time divided by 2 is the time taken for the sound to travel. And since you know the speed of the sound at a certain temperature, you can calculate the distance. And based on the distance, I am turning a motor, you know, in one direction or the other direction. And that requires another integrated circuit called a motor driver, because a typical motor cannot be driven directly from an Arduino pin. Motors require a bit more current, so I need to have something like a relay, but something which is a bit faster than a relay, which is this particular IC. Okay, and again, you don't have to know too much of electronics to be able to use it, as long as you follow the connections correctly, as long as you get some overview, which you will get if you follow my wiki. Okay, so here I have programmed it in such a way that if the distance is in a certain range, if I recall correctly, within 50 something centimeter or less than 50 something centimeter, it will rotate in one direction at, you can see at 4000 something RPM. You can't set the speed very exactly, but you can set the direction and some approximation of the speed. And if it gets closer, you see it starts rotating in the other direction. I move it away. This is an obstacle, okay? Something from which you will get an echo. If I move it further away, then it rotates in the other direction. And if I move it even further away, it rotates even faster in that direction. So you see the RPM, and the exact same connections done in real life will allow your motor to rotate like this. But like I mentioned, it's very hard to control the RPM exactly, but you can control it to some extent, okay, by doing some manipulation in your program. And the program is a bit more complicated, but not a lot more complicated. It looks kind of like this. So I measure the distance, and then I compare the distance to certain thresholds. So if the distance is greater than 50, I will rotate in one direction at max speed. If it is greater than 25 but less than 50, I'll rotate in the same direction but with 1/4 of the speed. And if it is less than 20, then I rotate in the other direction. And this kind of stuff can be very useful in robotic applications. Like for example, if you want to have a robot which will not collide with the wall, like for example, your robotic vacuum cleaners, yeah, they use a logic very similar to this. So you can do very similar stuff in, or without that much of a complicated code, and with a bunch of connections which are, okay, not too simple, but definitely not too complicated. Okay. And another example is, the last example would be using a light sensor. I have programmed in such a way that a light emitting diode will blink faster or slower depending on the intensity of light falling on it. So I have it somewhere here. Where was it? Yeah. So here I have a bunch of connections. Here I have a switch. I have a light emitting diode, but I have something called a resistor connected to it so that it wouldn't have too much of current and won't spoil. And then there is this component called light dependent resistor, which is fundamentally a resistor whose resistance, that is opposition to flow of electricity, will change depending on the amount of light falling on it. Again, these are very, very cheap stuff. You can buy it for a few cents. So I'm using this light dependent resistor to figure out what is the level of illumination in the room where I am in, and then take an appropriate course of action. So I start my simulation. Right now, nothing happens because the switch is off. I turn on the switch, and you can see an LED gradually turning on and gradually turning off. And when I increase my brightness, you can see that the speed has become remarkably low, right? So the rate at which it blinks has become much slower. This is just a sample application. You could do something even simpler, like if the light falls below a certain threshold, turn on something. Yeah. But this has a bit more logic than that. To turn it on gradually, turn it off gradually, rather than turn it on and turn it off abruptly, it requires a bit more logic. So you can see the corresponding code. It's a bit more complicated. Okay, but it's not particularly hard to figure out. Even if you are a beginner to programming, if you spend a few tens of minutes, you will be able to figure out what this program does. Okay, so I guess with these examples, I will stop for now. But you can see here, there are a bunch of exercises, all of which can be done using Tinkercad, even without the hardware. But of course, it's always a lot more fun to have the real hardware in front of you so that you can see it for real rather than on your computer screen, which is something which you should try out if you're really interested in all this stuff. And there are a lot more complicated sensors which are not particularly complicated to use, available in the market, which you can just buy, make the connections, following the tutorials on the internet. A number of tutorials are already provided here. Like for example, here I have examples for humidity sensor. For example, if you want to turn on the air con automatically if the humidity and temperature exceeds a certain threshold, you can use the sensor to figure that out and to take the appropriate course of action, right? And there are a lot of other sensors in the market. Like for example, here is another sensor, which is an accelerometer, gyroscope, compass, and altitude sensor, that is pressure sensor. Pressure is usually sensed using altitude. Okay, so all these combined into just one chip. You just need to make just 4 connections to Arduino and write your program to read the data from it. And again, you don't have to write the program from scratch. Just Google for the appropriate hardware plus Arduino and you will get sample programs. Just download it and modify it or tinker with it to get what you want, and you are good to go. Okay, so you can do a lot of interesting stuff. None of this stuff was imaginable 15 years ago or even 10 years ago. But now all these very cool sensors, components, ready-made software, all are available for you. Okay, so give it all a try. Okay, and yeah, have fun with it. And I hope this sharing session, even though I exceeded the time by a few minutes, sorry about that. I hope the sharing session was useful for you. And yeah, here is the wiki. So go through it step by step and try out things. And if you go through all the examples in the wiki, you will already have a fairly good understanding of how to tinker with all this stuff. And now I guess I can open the floor for questions. If you have any questions, I'll be glad to answer if I know the answers. I can't claim that I will know everything. Nobody can, because there are a large, huge number of hardware units out there. There are a large number of platforms which allow you to do interesting stuff. Nobody can know all this stuff, and nobody needs to know all this stuff. As long as you have the attitude to Google up for the required information, read up, understand, and try it out yourself, it's good enough. Oh yeah, one last example. Sorry, I forgot. If I may, this is another an Arduino board which is very similar to Arduino, which is from ST Microelectronics. And here I have connected it to Wi-Fi. And that allows me to see, or this has a bunch of sensors built into the board itself so that you don't have to connect it externally. I just named the board Chumma. So it has a bunch of sensors. So let's say if I look at acceleration and I can select real time and click play. So it will show you the acceleration reading. And now the only connection I have is a power connection. It has a built-in Wi-Fi module which connects directly to internet. Okay, connects directly to a certain website, and the website shows all the information you see here. And now when I rotate it, you can see the acceleration values will change because now the direction has changed, right? And a lot of other values can be measured, gyroscope. which is a rotation sensor. Let's say humidity. Now the humidity here is like 47%. It's a relative humidity. If I blow into it, you can see the humidity suddenly shoots up. And you can even write scripts here, which will look at the values and which will command or send commands back to this board to perform certain actions. And here I will show you a very simple command to turn the LED on and off. So I can give a command from the internet and it will cause a built-in LED to turn on. And I can turn it off. You see here, it turned off. It turns on. Okay, one of the 3 LEDs here. So you see, you can send commands from the internet and this board will obey those commands. So it essentially can share information with a website, with a server through some kind of internet connectivity, like for example, Wi-Fi. Okay, so there is this very cheap Wi-Fi module that you can buy from the market. This one, you just need to connect to the Arduino board using a bunch of wires. This one has a built-in Wi-Fi, but if you are using this one, you just need to make 4 or 5 connections to this board, and then your Arduino program, whatever you write, can talk to a remote server over the internet. And here again, you don't have to start from scratch. Ready-made codes are available. Just download it, make the connections, and you're good to go. You might just need to make some modifications here and there, like for example, your Wi-Fi password. And if you're connecting to a server, the server might require some kind of an authentication token. And the server name itself might change depending on the server you are using. So make some adjustments here and there, and you are good to go. That's the idea. Okay. So yeah, back to what I was saying. Yeah, I welcome any and all questions, and whatever I can answer, I'll be able to answer, or I will answer. So I guess if you need to be unmuted, you can let the admins know. Or I can already see a bunch of stuff in the chat. Oh yeah. What is the difference between Arduino and Raspberry Pi? Yeah, good question. I have mentioned some points of comparison here. Raspberry Pi is another very popular platform with hobbies like Arduino, which is also a small computer. But the typical applications we use it for are quite different. Arduino is what we call a microcontroller. Even though it's a small computer, we typically don't use the term computer along with Arduino. It's way less powerful than the typical computers that we think about, right? So we call it a microcontroller. So it can do only relatively simple computations. For example, if you want to detect something, like for example, the light level, and turn something on and off based on that, the amount of computations you have to do is quite minimal. Okay, read a sensor value, see whether it is greater than a certain threshold, and then activate something. It's not very complicated. So for those kind of applications, you can use Arduino. But if you want a lot more complicated stuff, like for example, if you want to have a server by itself, or if you want to have some kind of image processing, like for example, if you want to have a camera which takes photos or video of the stuff in front and detects the object that is in front of you and takes some course of action based on that, which is kind of how self-driving cars work, right? They kind of try to figure out what is the object in front of it, and based on that, it might apply the brakes or change lanes, etc., depending on the scenario. So those kind of stuff are impossible using Arduino because processing an image, processing a video, etc., require a lot more processing power, and there you can use Raspberry Pi. Okay.
Yeah. Now we have one follow-up question as well.
But more detailed more detailed comparison can be found here. But again, Raspberry Pi, even though it's way more powerful than Arduino, is still less powerful as compared to a typical computer, or what you would want from, or what you would want to power a self-driving car. Okay, but for many hobby applications, Raspberry Pi is good. Raspberry Pi runs a complete operating system like Linux, so you can use it more or less like a normal computer. Okay, but of course you need to have some familiarity with Linux to get the full power of Raspberry Pi, which is not very hard. Like Linux is the operating system I am using, in fact. Now
we have one question from Vinod as well.
Another question.
Hello.
Is
Dr. Rajesh?
Tinkercad free? Yes, it's completely free for trying out online. There is no equivalent of it which you can install locally. It has to be done on their website, but it's free, yes. Now, once you have an idea, and if you wish to deploy it, how do you make it into a standalone project without connecting to the laptop? Well, you need the laptop only for programming it. Once it is programmed, let's say once the programming is done, you could just simply power it onto or plug it onto a power bank. And you no longer require a computer connection. Once it is programmed, the program is already there in the memory of Arduino. Even if you reset, it's fine. Once it comes out of reset, there is a reset button here. So once it comes out of reset, it will start, running the code. And if there are other possible connectors too, like, this connector. So it can be used to connect to a battery pack. Like you can have like 4 1.5 volt batteries, connected using a, battery holder and then plugged onto here. Is using app to control switches example available? Well, a lot of examples are available in the internet. If you want to make use of the specific examples that I showed you today, just let me know and I will make it available. But it's not available in the wiki. It was just an example that I made a few hours before this session. Now, next question is it possible for Arduino to recognize sound and perform a task? The answer is yes. Okay, but Arduino does not have that much of a computational power to recognize sound the way you want. If you want a bit more advanced sound processing, you should probably use Raspberry Pi, which also has a jack for you to plug in your microphone. Arduino doesn't have that, but it's entirely possible to make Arduino do some kind of sound processing if you have a separate sound processing chip. Like you can buy those voice recognition chips and connect it to Arduino. So Arduino doesn't really have to do the voice recognition itself. The chip can be programmed to recognize a list of commands. Okay, and then Arduino can read that particular chip and figure out whether a particular command has been issued or not, and then take the course of action. Now, next question is, what is the name of the Wi-Fi board? That is, the one I am using is ESP8266. Okay, it's a very cheap, very powerful board, but there is a newer version of that board available, ESP32. All of them are well less than $10. ESP32 has Bluetooth as well. Okay, so if you want to have Bluetooth functionality as well, you can use ESP32. In fact, ESP8266 and ESP32 can be used standalone. Okay, it can be used in two different ways. One, it can be used as a helper add-on board to the Arduino board, or that itself can do pretty much everything that Arduino can do as well. Okay, so but you will need to install some additional libraries in your Arduino Ide to get started. If you want only Bluetooth, then there are cheaper Bluetooth boards available. Again, for less than $5 or thereabouts, you can buy those boards. Just make a couple of connections to Arduino, and you have ready-made libraries to make use of the Bluetooth. Now, out of the two, which one is cheaper? Well, Arduino is cheaper, way cheaper than Raspberry Pi. Arduino is, okay, depending on where you buy from, it can be in the range of $5 to $20, $5 to $30, depending on where you buy it from. Whereas the Raspberry Pi would be $50 odd. Is there any website that we can buy Arduino Uno board or components? Local website would be RobotRS, which has most of the components available locally. But and there is also a shop in Simlim Square. There is also an online shop called SG Botic. Just Google for these, and they have pretty good websites where they have listed everything, and you can order online. But of course, if you buy it online, it will be, I mean, buy it locally, it will be costlier as compared to, buying it from those websites in China. Yeah. Is there any question that I have missed?
Sorry, I'm Prem. I just
one last point. When you compare Arduino versus Raspberry Pi, it's usually not, I mean, cost is usually not the main consideration. It's usually capability. If you want more or less like a full-fledged computer, you go for Raspberry Pi. Whereas if you want a relatively simple processing, you would probably go for Arduino. Yeah, there are official Arduino boards. There are clones available. Of course, the clones are cheaper, but less reliable. Whereas if you buy the official Arduino ones, it's a lot more reliable. I would say if you're a beginner, you should get started with Arduino. Raspberry Pi requires a bit more advanced knowledge. And it's also quite easy for you to spoil the Raspberry Pi if you're not careful. Whereas Arduino is relatively hard to spoil. Okay, and it's also a lot easier, a lot more examples, etc. are available for Arduino as compared to Raspberry Pi. So start with Arduino and then graduate to Raspberry Pi.
Sorry, can you hear me? I'm Prem. Sorry, I just want to say to the participants, if you have a question, you can also unmute and ask question. Because since the main session is over, we can all speak now.
This is Ullas here. Very good
Hi,
session,
Ullas.
Rajesh.
Yeah,
really appreciate. I think it is an excellent start for somebody who's interested to start something like this. Thank you very much. Fantastic.
Thanks. Thanks a lot for appreciating it. And I hope, everyone in the audience, if you're new to all this stuff, has some motivation to get started now after realizing that these things are not as difficult as it seems to if you're totally new to it.
Yep.
Thanks, Rajesh. It was really useful, very informative, and especially the Tinkerboard one. I was not aware. I think it was very interesting.
Mm-hmm.
Thanks for the support, and I think you'll be continuing with more sessions in the days to come.
Sure. Yep. And
Yeah,
if you're a beginner, it certainly helps to get started with Tinkercad because you can do pretty much everything virtually without risking spoiling your hardware.
True.
Yeah, I realize that lots of people are like ready to get their hands on it. So we have a follow-up session as well, luckily. So sorry, are you guys able to see my screen? So just a moment. Yeah, so we'll have a Arduino workshop coming up on the 1st of August. So we'll have it in limited slots, as in 15 people or so, owing to the current COVID situation. And we'll also have a follow-up session and also one more talk coming up, which is the magic behind Google search, where Malavika is going to be explaining a bit about recommender systems and what goes into them. So for the Arduino workshop, you can register using the links provided. For the people who have joined previously, thanks for finding time this week as well. Now, for the newer members, I hope you enjoyed the session. So we can still continue the talk, and then I'll get to the rest of the matters. So if you have any more questions, please do go ahead.
So yeah, there is another question here. Can you teach us to build our own PC, like step by step? Well, it's possible, just that I can't do it virtually, but I can certainly give some instructions if you are interested. Of course, we will have to possibly make a trip to Simlim Square together, buy all the components so that we can put things up together. But if you want to know those stuff in a lot more detail, down to the level of ones and zeros, you can join NUS in electrical engineering or computer engineering, and we go all the way there. And Malavika was my student a few years ago, and she was in my class on computer architecture, where we go into very, very, very fine details of all this stuff. But to put a computer together, you don't need to know anywhere close to that. In fact, it's very hard to make or get assembly of a computer wrong, because almost every connector is designed in such a way that you can't connect wrong. It's all, for the most part, foolproof. And yeah, just need to, depending on the configuration you want, just buy the appropriate components, put them up together. And if you need assistance with that, please let me know. I'll be glad to help.
From our side, like we have put up all the links in the chat window, like some good news from our side as well. So if you know, like Robin had presented a session last week. So congratulations, Robin. So Robin has been selected as the global finalist for the NASA Space Apps Challenge. This year, NASA Space Apps Challenge is looking specifically at COVID-19 situation and the solutions. It can be the various solutions that can be used. And Robin's solution is one among the global finalists that has been chosen. So congratulations, Robin. It's always good to see Tech Forum members making their mark. And thanks, Dr. Rajesh, for the session. Like what I enjoyed about it was like, it was interesting enough to see all these applications and get simple enough for an amateur to get started. So all the members, like you can provide your feedback through the link provided. We'll also be sharing them in the chat window, and do reach out to us if you're interested in speaking as well. So thanks everyone for joining in. I call upon Prem Chetan for any closing remarks that we have.
Okay,
maybe before that, let me just thank my audience. I really appreciate that so many of you joined the session today. And I really hope you learned something from the session and you got motivated to try out things. And once again, let me thank SMA for inviting me to do this talk. Thank you all. Thank you, everyone.
Thank you very much, Rajesh. It was a really a very good talk. I'm an IT person, but a lot of things you said new to me or reminded me of the basics. Thank you very much. That was really good. And I'm sure that with the kind of interest the people were asking, I'm sure that has created some interest, and there'll be activities. So those who are interested, please sign up for the hands-on workshop. and definitely that's the best way to learn, I believe. You have to get your fingers dirty, hands dirty, to get a hand and we can definitely assist with that. And somebody was asking about assembling a computer. I mean, that can be one of the things we can probably look at it. If you are interested in some topics or anything technical, there's a feedback form which we are posting in the chat window. We'll also be sending that in an email to all the participants. So in your feedback form, if there is some specific area you are interested in, please indicate it, and we'll see whether if we can organize. Definitely, we'll organize that. So that'll also give us some guidance on what you would like to hear, and probably we can organize that. Thank you very much for everyone for joining, and Rajesh, thank you again. It was a very good thing, a very good session, Rajesh. Thank you.
Oh yeah, one last point. This Tinkercad can be used to simulate a lot of stuff other than Arduino. Like for example, your secondary school or junior college circuits that you might learn, like parallel circuits, serial circuits, connecting batteries, measuring current, measuring voltage. A lot of stuff can be done on Tinkercad. Yeah.
Are there any more questions? Anyone has a question? You don't have to type, but I think you can basically unmute and ask if you have any questions or anything you would like to know. You don't have to be shy. Okay, looks like there are no more questions. Balu, back to you.
Yeah, I think if there are no more questions, then we can wrap up. So again, remind you guys again, you can provide the feedback for this session through the link provided. We have already shared the link in the chat as well. So hope to see you for the upcoming sessions as well. Please join us if you're interested in hands-on work as well. So Arduino Workshop would be on 1st of August, and the next talk will be following in the 6th of August. Thanks everyone, and have a good night.
Okay, thank you.
Thank you.